Okay, we're on page 10 of section 2.2. So we're going to learn about some applications of slope. How do we use slope in the real world? How could you figure out what's the best price to sell hot dogs at? So that's what this problem's about. That's why I said that. So there's a vendor, and he found that when he priced the hot dogs at $1.25, he would sell 123 hot dogs per day. When he priced the hot dogs at $1.75, then he would only sell 101 hot dogs per day. So the first thing I notice is, okay, as the price goes up, the number of hot dogs sold goes down. Because one of the numbers is negative, it's going down. You can guess that the slope would be negative, because as the price goes up, the number of hot dog sales goes down. So if one of them gives us a negative, we know that a positive divided by a negative is always going to give us a negative. So when the line falls from left to right, that means it's a negative slope, and that's what this picture has. So you might not see it, but $1.25, 123 hot dogs is right there. And at $1.75, 101 hot dogs is right there. So those are the 2 points. We could even label them. So the price is X, so it'd be $1.25 goes with 123, and $1.75 is my X price, and the number of hot dogs is my Y, 101. So there's my 2 points. $1.25 price, 123 sold. $1.75 price, 101 sold. And remember, this is the price. This is the hot dogs sold. Because we're going to need this in just a moment when they ask us to explain slope. Okay. And they tell us that X is the dollars, which you can see. So price in dollars is X-axis, and the Y-axis is the number of hot dogs. So find the slope of this linear equation. Well, sometimes I don't give you a graph, and they'll just expect you to look at the problem and be able to find it. And because they gave us X was dollars and Y is hot dogs, we would know right away to write $1.25, comma, Y's number of hot dogs. So even without the graph, I think the graph helps us to see why the slope's going to be negative when we find it, but you really don't need it for this part of the problem. And $1.75, 101 dogs sold. So find the slope. So the first thing I do is I write my slope formula, because this has to be about 6 or 7. We should be memorizing it, right? Second y minus the first y over second x minus the first x. This is my first x, this is my first y, this is my second x, this is my second y. So second y, 101, minus my first y, 123, over second x, 1.75, minus my first x, 1.25. So this looks like what? Negative 22 over 0.5. And I never guess, so I'm just going to verify it with the calculator. So 101 minus 123, negative 22, good. 1.75 minus 1.25, 0.5, boom, we got it. So there's a couple things wrong with this problem. Well, the biggest thing is it's not simplified. The next biggest thing is you're never allowed to leave a decimal or a fraction in a fraction. So this tells me I need to use the calculator to simplify. So what a lot of students will do on this is they'll type in the fraction bar. Well, the calculator knows decimals and fractions can't be in fractions, so it's going to give you a big fat error if you try to type this in using the fraction key. So decimals cannot be in fractions, so it will give you an error if you try to put one in. So to simplify this, we'll have to use the division key. So negative 22 divided by 0.5 is negative 44. And that makes sense because it wants to know how many 1/2s are in 22. Well, there's 2 halves in every one, so 2 times 22, 44. How many halves fit into 22? 44. A lot of people think this means cut 22 in half. That means 22 times 1/2. This is 22 divided by 1/2. So picture 22 pizzas. You want to know how many half pizzas are in the picture. There'll be 44. 2 half pizzas per pizza. Okay, so now we have the slope. Now they want us to interpret it. And this was a huge part of Math 091. So slope is y. Division is read as per x. So every time we see a slope and we're asked to explain it, we have to remember the formula. Y, the y's divided by, which is the word per, just like miles per hour means miles divided by hours. So y's per x is how we label it. So if we were labeling this one, it'd be negative 44. I look on the y-axis and say, what is y? Oh, hot dogs. Then I use the word per. And then x is dollars. Or per dollar. We're only talking about one here. So think about what that means. Negative 44 hot dogs per dollar. So the bottom number is positive, so it's saying negative 44 hot dogs per $1. So that means as the price increases, because isn't this a positive one? See the positive? By $1, 44 less hot dogs will be sold. So every dollar you increase on the price, you'll sell 44 less hot dogs. And here it was just 50 cents. That's why we sold 22 less. But if it's $1, you'll sell 44 less hot dogs. So for every dollar increase in price, 44 less hot dogs will be sold. So you have to use your graph, you have to use your labels, you have to know the slope formula, and you have to know that slope is always labeled y per x because of the formula. Y per means divided by the x's. And so then I looked at my graph to find out what y was, to find out what x was, and I put the word per in. So for every dollar increase in price, so for every $1 increase in price, boy, I'm not doing very good, am I? So for every $1 increase in price, comma, 44 fewer hot dogs will be sold. So you'll have to find out where you make the most money by multiplying the number of hot dogs you sell by the price. So for every $1 increase, because it's positive in price, comma, 44 fewer, because we can't use negative 44. We can't say negative 44 hot dogs will be sold. We have to use a word that means a negative. So 44 fewer hot dogs will be sold. Okay, so let's look at these last two parts. This linear equation models the number of hot dogs Y sold per day when the price is X dollars each. Find the number of hot dogs sold when the price is $1.50. So the reason they tell you the variables, and I will tell you, the students that don't do well on these are the ones that don't read the problem, because you don't always plug in for X. Sometimes you plug in for X, sometimes you plug in for Y. So what you have to do is go, this is dollars, which one's dollars? Oh, X. So that means plug this in for X. So Y equals negative 44. And that means times X. So in this case, it's going to be times $1.50 plus 176. So price is 150. So in place of X, I put 150. And I have to know that that means negative 44 times X. So it means negative 44 times 150. And now we can plug it in our calculator. And remember, because it is a word problem, it does need a label. So negative 44 times 1.50 plus 176. And our calculator knows order of operations, so we don't have to hit enter until the end. So that's 110. So then we say 110 what? So this is Y. Y is hot dogs. Hot dogs will be sold. If the price is $1.50. Each. So 110 hot dogs will be sold if the price is $1.50 each. So it's not so bad, right? As long as you read the problem. Got to take your time on that. That's the most important part. Okay, according to your model, how many hot dogs would the vendor sell if the price was $4 each? Okay, so price again, remember, is X. So we're going to put this in for X. So Y equals negative 44 times 4 plus 176. So negative 44 times $4 each plus 176. Negative 44 times 4 plus 176. 0! We just priced ourselves right out of the market. So 0 hot dogs will be sold if the price is $4 each. So when we plug it in the calculator, it gave us 0, so that means 0 hot dogs will be sold if the price is $4 each. And there you have it. That's it for 2.2. So in the next video, we will start 2.3.